All right, y'all, we're looking at day 4 of our topic 13 notes. And we start off with an exercise that tells us right off the bat that between these two rectangles, each side is doubled. Okay, so on the top one, we've got a length of 2. On the bottom one, the one that matches it, is a length of 4. Okay, we've got a 3 and a 6 in between those two rectangles. Okay, it is asking us a very simple question. What is the area of the rectangles? Okay, so finding the area of a rectangle is a pretty simple process. Length times width. Okay, don't overthink this. The area of our smaller one, 2 times 3, is going to be 6 square inches. The area of the larger one, again, length times width. Don't overthink it. 24 square inches. Okay, now that is an interesting discovery that we've just made. Okay, because it told us directly that each side length was doubled, but the areas going from the small one to the big one, the areas are not doubled. The area of the bigger one is 4 times as much as the smaller one. Okay? Why is that? Why is it that if you double the side length, the area is now 4 times more? Okay? That's what we're going to be talking about today as we talk about the perimeter and area of similar figures. Okay? Similarity is something that we talked about early on in the semester. Go ahead and pause the video right now if you need to write down those definitions. Similarity is something that we talked about, and we said that in between similar figures, you've got the exact same angles. Okay, and as you can see on these two triangles here, you've got the exact same angles and you've got corresponding parts, but they're different sizes. Okay, and that's the point of similarity, is that not only do they have different sizes, the side lengths, because of those angles being the same, the side lengths are directly proportional to each other. Okay, so as you look at this particular picture, you've got proportional sides that correspond to each other. CA and FD, AB and DE, BC and EF, those are all sides that match up and correspond with each other. And they are all related by what we call a scale factor. Okay, a scale factor is the ratio of corresponding sides. Okay, so as we look at trying to find our scale factor, it is this ratio that we have in between the two sides in these triangles that we actually have values for. Okay, the corresponding parts of AB and DE give us a length of 6 and 4. And when we reduce that ratio down, it's 3 over 2. Okay, that right there is going to be our scale factor. Okay, that is our scale factor. It's the fraction of the corresponding sides. Okay, however, we also know that BC and EF are corresponding parts. We just don't know what x is equal to, so 7 over x. We also know that CA and FD are corresponding parts. We just don't know what y is. However, what we do know is that the scale factor is a ratio that is consistent for every single part of the triangle. Okay, every single corresponding side of that triangle is going to consistently have a scale factor of 3 over 2. So if we were trying to solve for x, we could say that this ratio, 3 over 2, is equal to the same ratio as 7 and x. Okay, comparing 6 and 4, that 3 over 2 is the same as comparing 7 and x for the other sides of that triangle. Okay, so if we're going to solve an equation that looks like this, it ends up being pretty simple. We're going to do a little bit of cross multiplying, something that we learned about in probably 7th or 8th grade. We're going to do some cross multiplying. So on one side of the equal sign, we've got 7 times 2, which is 14. On one side of the equal sign, we've got 3 times x. And it ends up being pretty simple, just doing a little division right there. We can get that x is equal to about 4.67. It's about 4 2/3 is what that is. Okay, 4.6 repeating is what it is. In the same way, I want y'all to do this one on your own, but in the same way, you could figure out that y is going to be equal to 5.33 repeating. Okay, I want y'all to do that one on your own. Just give it a shot, and if you end up with a different answer, other than 5.33, you let me know and we'll see if we can figure it out, all right? So that's how you would do that. This is something that we did early on in the semester, by the way. We've already done problems like this where you deal